Greetings, my lovely viewers. Today we are going to see conversion of numbers from order base to base 10. Conversion of numbers from order base to base 10. Now remember that number base is a system by which numbers are described in different groups or bases. When numbers are grouped in tens, that is base 10, we call it binary or decimal number. When they are grouped in twos, that is base 2, we call it binary number. Remember, we don't have anything like base 0 or base 1. It starts from base 2 to infinity. If you're in SS1 class, this topic is very important. Now, in number base, assuming you are working in base 5, we will not see 5 in your answer or any number greater than 5. If you are working in base 6, 6 will not appear in your answer, or any number greater than 6 will not appear in your answer. Why? When it reaches 6, it has makes a complete bundle. It will start from 0 again. Now, if you are working in base 2, the numbers that will show in your answer in base 2 are 0 and 1 only. If you are working in base 3, we have 0, 1, 2. If you are working in base 4, 0, 1, 2, 3. If you are working in base 5, we have 0, 1, 2, 3, and 4. As we are working in base 5, for instance, 5 in base 5 is equal to 1 remainder 0. It has makes once it reaches 5, it has makes a complete bundle of 1. Remember, and it will start from where 0 again. So we will not see 5 in this place or any number greater than 5 here. It will stop at where? At 4. So 4 is the greatest value when you're working in base 5. And 3 is the greatest value when you're working in base 4. 2 is the greatest value when you're working in base 3. Now, as when you're working in base 10, for instance, the digits are 1, 2, 2, 3, 4, 5, 6, 7, 8, and 9. 10 will not appear here because you're working in base 10. And once it reaches 10, 10 in base 10 is equal to 1 remainder 0. Once it reaches 10, it has makes a complete bundle. It will start from 0 again. And that is why in our normal counting system, we count in base 10. Our normal counting system, we count in base what? Base 10. So that is why when you have something like this, maybe you want to add, maybe I have 14 plus 6. 4 plus 6 is what? 10. I cannot write 10 here. It's not possible. Because we are counting in base 10, and this plus this is 10, and 10 in base 10 is equal to 1 remainder 0. So I will write this 0 here and take this 1 to the next number. So I have 1 plus this one give me what? 2. I hope it's clear. Now, also in subtraction, maybe I have something like 21, remove 5, take away 5 from 21. You can see that 1 minus 5, if it's children, they will say impossible. You go and borrow 1, add it and call it 10 and add it here. Why are you borrowing 1 here and calling it 10? It's true that we borrow 1 here and call it 10. Why would you call it 10? We are calling it 10 because this is in base 10. Like I said, our normal counting system is in base 10. We count in base 10. So that is why when you borrow 1 here, we call it that base. That base, which is what? Base 10. So we call it 10 and add it here. Here will be what? 11. So I will now say 11 minus 5 will give me what? 6. And this is 1 in base 10. I hope you are following. So now we are going to see how to convert numbers from order base to base 10. Like I said, I said that number base starts from base 2 to infinity. So you have base 5, base 7, base anything to infinity, from 2 to infinity. So let's see how to convert. The example says convert 2, 3, 4 base 5 to base 10. That I should take this 2, 3, 4, which is in base 5, I should take it to base 10. Now, watch out and see the procedure. I have 2, 3, 4 base 5. I should convert it to base 10. Now, in converting to base 10, I have to assign digits to these numbers, starting from right. Look. So the first thing I will do is to assign digits from 0, starting from right to left. So I have 0, 1, 2. If there's another number here, I'll label it what 3, and so on. Then I'll multiply. I'll say 2 times the base. The base is what? 5. 2 times the base raised to power 2. These two here, plus the next number is 3 times the base, which is 5, raised to power 1, plus 4 times the base, which is 5, raised to power 0. Are you following? Now, all these ones that has power, I have to expand it. When you have something like this, 5 raised to power 2, this 2 is the power, or you call it index, and 5 is called the base. When you have something like this, this is the base, and this is the power, or the index. So we'll continue. I have 2 times 5 raised to power 2. This is where some students make mistakes. 5 raised to power 2. 5 raised to power 2. It means multiplying this 5. This one is telling you how many times are you multiplying this 5. So it means that I'm multiplying this 5 twice, which is 5 times 5. Are you listening? Some students make a lot of mistakes here. They will say 5 times 2 or 2 times 5. No. It's not 5 times 2. It's not 5 times 2. It's 5 times 5. This one is telling you how many times you are multiplying this 5. So 5 raised to power 2, which means 5 times 5 is equal to what? 25. Plus 3 times 5 raised to power 1 is the same 5. Plus 4 times 5 raised to power 0. In mathematics, any number raised to power 0 is equal to 1 from laws of indices. Any number raised to power 0 is equal to 1. 100 raised to power 0 is equal to 1. 50 raised to power 0 is equal to 1. 1 million raised to power 0 is equal to 1. So I have 1 here. Then 2 times 25 will give me what? 50. Plus 3 times 5 will give me what? 15. Plus 4 times 1 will give me what? 4. I'll now add 50 plus 15 will give me what? 65. 65 plus 4 will give me what? 69. So therefore 2, 3, 4 in base 5 is equal to 69 in base 10. After calculating in base 10 or to any base you are asked to calculate, make sure you put that base there. Now let's see another example on how to convert numbers from other base to base 10. So this example says that we should convert 11011 in base 2 to base 10. So like I said before, this number is in base 2. You cannot see 2 or any number greater than 2 in this number, because it is already in what? In base 2. So in base 2, the digits will be seen there as 0, 1, 0, 1 only. So the greatest number in base 2 is equal to what? 1. So let's continue. I have 11011 in base 2. So the question says that I should take it to base 10. So I said you are going to start from the right to assign digits to this number. So I start from 0, 1, 2, 3, 4. If you have other numbers, you continue. So I will now multiply. The first one is 1. 1 times the base. 1 times the base raised to power 4. So the base is 2 raised to power 4 plus the next number 1 again. 1 times the base raised to power 3 plus the next one is 0. 0 times the base raised to power 2 plus 1 times the base raised to power 1 plus 1 times the base raised to power 0. So I'm going to expand all these one that has power. So I have 1 times 2 raised to power 4. Remember that I said 2 raised to power 4 does not mean 2 times 4. 2 times 4, no. It means, look at it, 2 raised to power 4 means 2 times 2 times 2 times 2. 2 into 4 places. So 2 times 2 is what? 4. 4 times 2 is what? 8. 8 times 2 is what? 16. So I'll write 16 here. Plus 1 times, this is 2 raised to power 3. So I'll claim 1. So it means 2 times 2, 4. 4 times 2, 8. So this is 8. Plus 0 times 2 raised to power 2 is equal to what? 4. Plus 1 times 2 raised to power 1 is equal to 2. Plus 1 times, remember that I said that any number raised to power 0 is equal to what? 1. So 1 times 16 is what? 16. Plus 1 times 8 is what? 8. Plus 0 times 4 is 0. Plus 1 times 2 is 2. Plus 1 times 1 is what? 1. Now I will add 16 plus 8 will give me what? 24. 24 plus 0, 24. 24 plus 2, 26. 26 plus 1, 27. So, which is in base 10. This is 11011 in base 2 is equal to 27 in base 10. Remember to always put the base which you converted to. I hope it's clear. Also see another example on how to convert from other base to base 10. Look at this number 11.01 in base 2. Now we should take this number to base 10. Some students, once they see decimal point and what they are solving, they begin to panic. Don't panic, it's very, very simple. So I have 11.01 in base 2. Now we should also take it to base 10. So the same way, in this place, this is the whole number part. Then this decimal point and this decimal number. So that whole number part, I'll label it 0, 1. Then after the decimal point, the next number will be minus 1, followed by minus 2. If there's another number here, I'll label it minus 3. Then I'll multiply, starting from this place. I'll say 1 times the base 2 raised to power 1 plus 1 times the base raised to power 0 plus 0 times the base raised to power minus 1 plus 1 times the base raised to power minus 2. I'll now multiply out. This is 1 times 2 raised to power 1 is equal to 2 plus 1 times 2 raised to power 0 is equal to 1 plus 0 times 2 raised to power minus 1. From the laws of indices means 1 over 2 plus 1 times 2 raised to power minus 2 also means 1 over 2 raised to power 2. This is 1 times 2 is equal to 2 plus 1 times 1 is equal to 1 plus 0 times 1 over 2 is equal to 0 plus here First of all, I will say 2 raised to power 2. What is 2 raised to power 2? It means what? 4. So 1 times 1 over 4 will give me 1 over 4. I'll now add. 2 plus 1 is equal to 3, plus 0, 3, plus 1 over 4. This is 3 plus 1 over 4, which implies 3 plus 1 over 4. If I take 1 over 4 to decimal, it means 0.25. So finally, I have 3 plus 0.25 will give me 3.25 in base 10. So it means that 11.01 in base 2 is equal to 3.25 in base 10. I hope it's clear.